Every morning, we zip our jackets, snap our buttons, and turn our keys. We interact with hundreds of objects every day, often without considering why they look or feel the way they do. Consider the standard ballpoint pen. Right at the top of the cap is a tiny circular opening. If a cap is accidentally swallowed, this opening creates a path for oxygen. It is a safety feature designed to keep the airway open until medical help arrives. When a common 10-cent pen is manufactured with a life-saving mechanism, it suggests that other small, overlooked details might also serve specific functional purposes. This mechanical foresight is common in aviation. Passenger airplane windows contain a small hole at the bottom of the pane, known as a bleed hole. This diagram shows the plane's 3-pane window system. Cruising at 30,000 feet creates a pressure difference between the cabin and the thin outside air. The bleed hole allows pressure to balance between the panes, ensuring the outer window carries the load without cracking. We see similar reinforcements in our clothing. Most denim jeans feature small copper buttons pressed into the corners of the pockets. These are rivets. When jeans were first produced for miners, the fabric often tore at the seams under the weight of tools. These copper anchors were added to reinforce the high stress points of the garment. Whether managing atmospheric pressure or mechanical friction, these small additions are what prevent structural failure. Other features guide our behavior through touch. On a standard keyboard, the F and J keys have small raised bumps. These serve as a physical home base for your index fingers. They allow a typist to orient their hands correctly by feel, maintaining speed without needing to look down at the keys. Measuring tapes use a similar logic. The metal tab at the end has a small slot designed to hook onto a nail or screw, allowing one person to take long measurements alone. Consumer packaging also uses geometry to solve small problems. The hole in a soda can tab is designed to act as a straw holder. Once the can is open, you can rotate the tab and slide a straw through the opening to keep it from floating. Even the diamond-shaped patch on a backpack, called a lash tab, has a specific history. The two slits allow users to thread cord or carabiners through the patch to secure extra gear to the outside of the bag. Usability is often about these physical cues that direct our hands toward the correct action without the need for a manual. Some features are meant for the machines that make the products. The colored blocks on the crimped end of a toothpaste tube are often the subject of health myths. The industry refers to these as eye marks. They serve as high-contrast targets for sensors on factory assembly lines, identifying the exact point where a continuous sheet of plastic should be cut and sealed. When the sensor identifies the mark, the machine triggers the mechanical press to clamp down, ensuring every tube is the exact same length. Maintenance also requires these small modifications. The tiny hole next to a padlock's keyway allows rainwater to drain to prevent rust, and provide support for applying lubricating oil. On a smartphone, the small dot near the camera lens is a secondary microphone. It is positioned to capture environmental noise, so the phone's processor can filter it out during video recording. Standardized manufacturing and long-term maintenance are made possible by these physical protocols, even if they remain unnoticed during daily use. From safety mechanisms in pens to sensor targets on a factory floor, the objects we own are full of intentional, microscopic problem-solving. This brilliant functional design often goes unnoticed in our daily lives, simply because it performs its task perfectly, without ever requiring the user's conscious attention. Which of these details surprised you the most? Share your thoughts in the comments, and subscribe as we look closer at the world around us.